Hello guys, this is a video solution for problem sheet for week 9. There are 6 questions. I will go through every one of them and give you a detailed solution. Right, and please note that this video solution is on top of the typed solutions and the handwritten solutions, both of which you can find on the course website. Question 1. Show all right. So you may recall there are 6 conditions that we need to check. Right. The first condition is that u comma 0, which is u times 0, which is equal to 0, so it's satisfied. The second condition is that c of 0 comma u, so 0 times u, which is 0, so it's satisfied. Condition 3 is that c of 1 comma u, which is 1 times u, which is equal to u, satisfied. Condition 4, c at u comma 1, which is u times 1, which is equal to u. And condition 5 is the partial derivative with respect to u1 of this, which will be u2, and this is non-negative, right? So that is satisfied too. And finally, condition 6, the partial derivative with respect to u2 of this. So this will be u1, which is non-negative. So all 6 conditions are satisfied. So hence, the conclusion is that right, this is an easy example. Let's go to the next question. Question 2. Question 2 is to show that right. So let's start with first part, which is c u comma 0 is equal to the minimum of u and 0, which is 0, so it is satisfied. Condition 2, and this is the minimum and condition 3 it is satisfied. Remember, u is the 2 arguments u1 and u2 are numbers between 0 and 1. So the minimum of this is u, right? And this is minimum of u and 1, which is u. And condition 5 is to find the partial derivative with respect to u1 of c, right? And this is the same as the partial derivative with respect to u1 of the following. Now the minimum can take two possible values depending on, it can be equal to u1 if right, and it can be equal to u2 if, okay. Now if you differentiate each of these with respect to u1, you will get the following. You will get 1 if, okay, and 0 and clearly this is non-negative. So condition 5 is satisfied, right? And finally condition 6. You can do it similarly, right? So this is going to be the partial derivative with respect to u2 of the following: u1 if this is the case, and u2 if this is the case, right? And if you differentiate, you get 0 if u1 is less than or equal to u2, and 1 if u1 is greater than u2, right? So hence this is non-negative, right? So hence we have shown C is a copula. Okay, so that's question 2. Now question 3. Question 3 is the following: show that right, where theta is a number between 0 and 1, but including 1, not including 0, right? And we want to show that this is a copula. So the first part is always the easy part. So you have C of u comma 0. So it's going to be u times 0 times e of minus theta log at u minus log at 0. Because of the 0 here, everything has to be 0, right? So condition 1 is satisfied. Condition 2, C at 0 comma u So it's going to be 0 times u times once again, because of the 0, this thing is 0, right? And next is here CF 1 C of 1 comma u, and this is going to be 1 times u times theta times log of 1 times log of u. Now log of 1 is 0, so everything inside here, everything over here is 0, and e of 0 is 1, so this is equal to u. So condition 3 is satisfied. Condition 4 is u comma 1, which is going to be u times 1 times again log of 1 is 0, so everything here is 0, e of 0 is 1, so this becomes equal to u. Right? Now condition 5, we need to do the partial differentiation with respect to u1. Like this. Right, now to do the partial derivative you need to use the product rule, because you are dealing with this term here, right? You want to differentiate this with respect to u1, so you have to use the product rule. I'm sure you know. So if you do that, so it becomes u2 this is the first term you will get, all right? And the second term you will get is the following. Multiplied by minus theta over u1 times log of u2. So this is what you will get after using the product rule. Okay. Okay. So now if you combine, if you simplify this, you will get the following: ef minus theta, that's a common term. Right, and then the u1 here and the u1 cancels. u2 is a common term too, so you can pull out the u2 here. Then you have 1 minus theta times log of u2. Right? This is what you have. Now we need to show that this is non-negative. Now remember, u2 is a number between 0 and 1. So log of u2, by log of a number between 0 and 1 is less than or equal to 0. Theta, by definition, is a number between 0 and 1. Minus of log of u2 is going to be non-negative 2. So this whole thing, right, is going to be non-negative. I hope you follow, because that's the reason is that theta is non-negative, minus log of u2 is non-negative, so the whole thing has to be non-negative. And we know that u2 by definition is non-negative, and e of anything, e to the power anything, has to be non-negative. Right, so we have shown that this is greater than or equal to 0. So condition 5 is satisfied. I hope you follow my explanation. Right, and the final condition we need to check is condition 6, so which is the partial derivative with respect to u2 of this. Now if you apply the product rule one more time, I'm not going to go through the process, I'm sure you know what to do. So this is what you will get after applying the product rule and simplifying things. Right? The argument is the same as in part 5. U1 by definition is non-negative. EF anything has to be non-negative. Right? Now log of U1, because U1 is a number between 0 and 1, is less than or equal to 0. But theta is non-negative. Minus of log of U1 will be non-negative, and hence what is inside here, right, has to be non-negative. Right? So hence we have shown that this is non-negative. So hence C is copular. All right, so this completes question 3. Next is question 4. Is to show that where phi is a number between -1 and +1. Right, it's a copular. Right. So condition 1, we need to show that C at u comma 0 is going to be u times 0 times 1 plus phi times 1 minus u times 1 minus 0. Right? And clearly, because of this 0, this is equal to 0. The next one is C, okay, like this. C of 0 comma u is going to be 0 times u times 1 plus 5 times 1 minus 0. Okay, and again, because of the 0, this is going to be 0. Alright, condition 3. So you see at 1 comma u, this is going to be 1 times u times 1 plus phi times 1 minus 1 times 1 minus u. 1 minus 1 is 0, so this entire thing is 0, so you get this equal to u. So condition 3 is satisfied. And condition 4, C of u comma 1 is u times 1 times alright, 1 minus 1 is 0, so this whole thing is 0, so you get u, which says that condition 4 is satisfied. Now condition 5, you want to find the partial derivative with respect to u1 of this term, this expression here. So once again you need to use the product rule. So once again you will get two terms. The first term is going to be this. Alright, and the second term is going to be minus 5. And this is a bracket, okay? Now you should combine these two terms together, you will get the following. I hope I'm right. Alright, okay, this is what you will get, I think. Yeah, okay, now we need to show that this is non-negative. So let's see what we can do. Alright, we know that u2 is a number between 0 and 1, so it is non-negative. And similarly, 1 minus u2 is also non-negative, right? And phi, we know it goes from, the question says it goes from minus 1 to plus 1, right? Okay, now 1 minus 2u, 1 minus 2u, because u1 is a number between 0 and 1, right? It goes from, when u1 is 0, this will be 1. When u1 is 1, this will be minus 1. So once again, this goes from minus 1 to plus 1. Right? Okay, so you have three terms here. The first term goes from minus 1 to plus 1. The second goes from minus 1 to plus 1. The third term is greater than or equal to 0. Right? Actually, it takes values between 0 and 1, right? The third term. Okay, so the product of the three terms, right, must takes values between minus 1. So if I may write it here, the product of the three terms must takes values from minus 1 to plus 1. I hope you understand the logic, because the first term takes values from minus 1 to plus 1. So is the second term. The third term takes values from 0 to 1. So the product of the three must take values from minus 1 to plus 1. And you're adding a plus 1 on top to this, right? Hence, what is inside the brackets must be non-negative, right? Because you are adding plus 1 to the range from minus 1 to plus 1. So hence, we have shown that this is non-negative. I hope you follow my argument, right? The reason for that, the product of the three terms takes values from minus 1 to plus 1, But if you add a positive number, positive 1 to this range, it must take values from 0 to 2, which is non-negative, right? Okay. So condition 5 is satisfied. Now, condition 6 is similar argument. So condition 6. After using the product rule, this is what you will get. Okay, right. So the argument is that u1 is non-negative, right? Phi, we know it takes values from -1 to +1, and 1 minus u2, we know that it takes values from -1 to +1, and 1 minus u1 takes values from 0 to 1. So if you take the product of these three terms, right, the product of these three terms, right, must take values from -1 to +1. But you have a +1 outside. So if you add a 1 to this range, the values must go from 0 to 2, which is non-negative. All right, so hence we have shown that this is non-negative. So hence all 6 conditions are satisfied, and C is a copula. All right. Okay, so that completes question 4. Next question is question 5. Is to show that the following is a copula. Right. Okay, so condition 1 is this. So it's, you put u and 0, so it's going to be u plus 0 minus 1. In brackets you have 1 minus u. Okay, so this becomes u minus 1 plus 1 minus u, which is 0. So condition 1 is satisfied. Condition 2 is C 0 comma u. You put becomes 0 plus u minus 1 plus 1 1 minus u like this. Okay, so this becomes u minus 1 plus 1 minus u, which is 0. So condition 2 is also satisfied. Okay, condition 3 is the following: C u comma 1, which is u plus 1 minus 1 Okay. Now 1 minus 1 is 0, so this becomes u plus zero to the negative power minus 1. Now 0 to the negative power is infinity, so this becomes u plus infinity minus 1. Now infinity plus a constant is infinity, so this is u plus infinity to a negative power. And infinity to a negative power is 0, so it's u plus 0, which is u. So condition 3 is satisfied. Condition 4 is similar, so let me do that. So condition 4, let's see, 1 comma u, 1 plus u minus 1 in brackets, 1 minus 1, yeah, so this is u plus 0 to the negative power plus 1 minus u minus 1. And this is once again equal to infinity, so you have infinity plus a constant, which is this. Okay. Now infinity plus a constant is infinity, right? And infinity to a negative power is 0, so condition 4 is satisfied. Alright, now next condition is condition 5. So we find the partial derivative of the function c with respect to u1, right? So, and if you do that, you will get this. Right. Now this we can write as follows. Right. Okay, now let's look at the term inside the square brackets. Now this term here, because u1 is a number between 0 and 1, and you're taking a negative power of a number between 0 and 1, this has to be greater than or equal to 1. And for the same reason, this has to be greater than or equal to 1. And this is also greater than or equal to for the same reason, this has to be greater than or equal to 1. Now this minus 1 right, has to be greater than or equal to 0, right? So what you have is this. You have a number that is greater than or equal to 1 divided by a number that is greater than or equal to 1 plus a number that is greater than or equal to 0. So hence, this fraction here has to be less than or equal to 1. Right? So 1 minus this fraction to the power this has to be greater than or equal to 0. So hence condition 5 is satisfied. Right? I hope you follow my argument. I will repeat that one more time for condition 6 so you can see what I mean. Right, so this is the final condition, condition number 6. Right? So here you're taking the partial derivative with respect to u2. Okay? And if you do that, this is what you will get. You get 1 minus u2 then in brackets you have okay. Now this you can write as follows: 1 minus, in big brackets, you have this, on the top you have this, and the bottom you have all right, this whole thing power alpha plus 1. Now the argument is the same as before, right? This guy here, because u2 is a number between 0 and 1, has to be greater than or equal to 1. The same argument applies to this. The same argument applies to this, right? Now if you put these two together, right, that is, a number greater than or equal to 1 minus 1 has to be greater than or equal to 0, right? So you have a number greater than or equal to 1 plus a number greater than or equal to 1 plus, divided by a number greater than or equal to 1 plus a number greater than or equal to 0. So the fraction, which, I mean, when I say fraction, I mean this term here, this fraction, right, has to be less than or equal to 1. I hope you follow. That's because you have a number greater than or equal to 1, which is divided by a number greater than or equal to 1 plus a number greater than or equal to 0. So this whole fraction has to be less than or equal to 1. Right? And to the power alpha plus 1 also has to be less than or equal to 1. Hence, 1 minus has to be, that fraction has to be greater than or equal to 0. So hence condition 6 is satisfied. So hence C. Right, finally question 6 is as follows, all right, is to show that right? Show that this is a copula. Alright, so the first thing you need to do is condition 1. So C u comma 0. Right, so for u comma 0 is this condition is satisfied because u2 is 0. Alright, so it's gonna be u to the power 1 minus alpha multiplied by 0, which is 0. So condition 1 is satisfied. Condition 2 is C 0 comma u. For this condition is satisfied because u1 is 0. So this is going to be 0 times u to the power 1 minus beta, which is 0. And condition 3, C u comma 1. Right, for this condition is satisfied because u2 is 1. So it's going to be u times 1 to the power 1 minus beta, which is u. Alright. And condition 4, C 1 comma u. For this condition is satisfied. Right. So it's going to be 1 to the power 1 minus alpha times u, which is u. And 5, you need to find the partial derivative with respect to u1 of this. So finding the partial derivative amounts to finding the partial derivative of each of these, right? So that's what I'm going to do now. So it's going to be the partial derivative of this with respect to u1, which is right, if all right, and the partial derivative of this with respect to u1, which is right. And clearly, because alpha is a number between 0 and 1, these two are non-negative. So condition 5 is satisfied. And finally, condition 6 you take the partial derivative with respect to u2, so you will get the following. So you differentiate this with respect to u2 and this with respect to u2. Alright, so you will get and this is clearly greater than or equal to 0 because beta is a number between 0 and 1, right? So hence we have shown that C right, so this completes question 6.